Hey everyone, welcome to mini lesson number 8, which is where we're going to talk about the average value theorem, the average value formula. This is section 5.4 in your textbook. Two different ways to calculate an average value. And this is why we're going over this, because these two different ways, depending on the way the problem is asked, is why people mess it up. If you want to calculate the average of the function that you have, we use the average value formula. 1 over b minus a, integral from a to b of the function. So if you have velocity and you want average velocity, you do this. If you have degrees per centimeter and you want the average degree per centimeter, you do this. If you want the average of what you have, you do this. If you want the average of the derivative of what you have, then we do the slope between the 2 points. So if I have position and I want average velocity, I have position, but I want average velocity, that's slope between 2 points. If I have degrees and I want degrees per centimeter, then I need the slope between those 2 points. This is why this is confusing. It depends on what you're given is how you do the problem. One of the most confused topics on the AP test, which is why I'm dedicating extra time to a mini lesson for it. We're going to do this problem entirely on the calculator to show you how to use your calculator to do this, to make sure that you use it on the AP test. The AP test is timed, so I want to do as much on the calculator as possible. I want to avoid doing problems by hand when at all possible. I might do 1 or 2 of these by hand, but the rest of them I'm going to do on the calculator, and I'll show you the steps. What's the particle's velocity at t equals 3? Well, I have velocity. This is a really easy problem. Just plug in 3. And if you do that, you get -9. No units given, so no units in the answer. That's an easy problem. What's the particle's displacement from 0 to 3, or over the first 3 seconds? Well, if you have velocity, and displacement is a position problem, how do I go backwards from velocity to position? I integrate from 0 to 3. X cubed minus 6x squared plus 5x plus 3 dx. Now here's what I mean by doing it on the calculator. If you want to do this by hand, the antiderivative is 1/4 x to the 4th minus, 2x cubed plus 5 halves x squared plus 3x evaluated from 0 to 3. That takes some time. Let's use the calculator. Let's plug in our graph, y equals, second trace 7 for integral. The lower limit is 0, the upper limit is 3. Answer, -2.25. So, -2.25. You ended up behind where you started because your velocity has some negative to it. No units in the problem, so no units in the answer. What's the total distance traveled? This is a different problem. This isn't displacement, this is total distance. Well, this is displacement. So how do I turn displacement into total distance? Absolute value. You have to have a calculator to be able to do this problem. So I go to my y equals, and I need to insert some absolute value bars. So I want the absolute value of the function that I had. So now my function looks similar, except there's no negatives to it. Second trace, integrate to 7 from 0 to 3. 11.554. Okay? Have to do that problem on the calculator. Okay, we're getting to the average stuff now. What is the average velocity of the particle from 0 to 3? Well, you're given velocity and you want velocity. You're given what you want. Since these two are the same, I'm going to use the average value formula. In this problem, it's 1 over 3 minus 0, the integral from 0 to 3 of vt dt. Luckily, we've already done this part. This was the very first problem I asked you, or the second problem I asked you. What was the answer to this? Negative 2.25. You can do it again on your calculator if you want to prove it to yourself, which is negative 3/4, or negative 0.75, whatever you want us to write. Why did I do average value formula? Because I wanted the average of the function I was given. What's the average acceleration of the particle? Different problem. This is the derivative of what I was given. Because this is the derivative, this means I want to do slope. And if I want to do average slope, I want it at 2 points. So I need to find 2 points. Well, I know 1.0 comma something, 1.3 comma something. How do I find my comma somethings? Let's go back to my equation, and let's get rid of the absolute value bars, because I don't need them anymore. How do I find points? Let's look at the table. 0 comma 3, and 3 comma negative 9. So let's do the slope between these two things. Let's do 3 minus negative 9 over 0 minus 3. And I believe the answer there is negative 4. Okay? Why didn't I do the average value formula? Because I want the derivative of what I was given. What's the acceleration at t equals 3? So I want an instantaneous. Acceleration is the derivative of what was given. So let's take the derivative. If you want to do it by hand, you can. I'm not going to. Again, I'm going to use my calculator. Second trace, 6 for derivative. At what point? 3. Now, the calculator estimates. I don't want you to estimate. What is that? That's negative 4. Okay? If I tell you the calculator is required, use your calculator. You only have a certain amount of time. Is the particle speeding up or slowing down at 3? Let's try to review what speeding up means. If you speed up, that means that velocity and acceleration are the same sign. They're both positive, you're going faster forward, or they're both negative, you're going faster backwards. To slow down, velocity and acceleration are opposite signs. So let's find the velocity at 3 and the acceleration at 3. Well, the acceleration at 3 I just found was negative 4. The velocity at 3, if I want to do it on the calculator, I just plug in the value at 3. The velocity at 3 is negative 9. I think I did that problem earlier. Since they're both the same, they're both negative, so it's speeding up. It's going backwards, and it's being pushed backwards, so it's going backwards faster. Okay? That was with an equation. Now let's do the same thing, but with a table. An 8-foot snowman begins to melt. The rate at which the snowman's height is changing in inches per hour is that function. The first thing you've got to realize is that this, like velocity, is a derivative function. How do I know it's a derivative function? Because it's inches per hour. So when I integrate this thing, inches per hour is going to turn into inches of change over blank number of hours. How do I integrate a table, though? I can't plug it in the calculator. I can't do the antiderivative. Well, there's a couple different ways. In this problem, it wants me to use LRAM and RRAM with 4 subintervals. If I do LRAM, that is 1 times negative 2 plus 2 times negative 3 plus 3 times negative 5 plus 4 times negative 1, and that is negative 27 inches. I didn't want to know that though. What does that mean? That means that this thing got 27 inches shorter over time. But I want to know the height of the snowman. The snowman started out at 8 feet. He lost 27 inches. Well, 8 feet is 96 inches minus 27 inches. So I know that after 10 hours, this snowman is 69 inches tall. Okay. RAM is almost the exact same problem. It's still going to be 1, but this time I'm going to use negative 3, 2 and negative 5, 3 plus and plus, 3 and negative 1, plus 4 and negative 6. That's going to be negative 40, which means that the snowman started out at 96 inches. He lost 40 inches, which means that he is now 56 inches tall after 10 hours. They're not the same. They're approximations. Okay? What does that represent? Oh, I used the wrong notation. Sorry. What does that represent? And what are the units? Well, that's the average value formula. So it's the average of what I have. So it's the average. What do I have? Rate that the snowman is melting. Rate of the snowman's melt. Snowman. Over 10 hours. That's all this problem wanted to know. Wanted to know the explanation. What are the units? It's the same unit as M&T. It's inches per hour. You will see problems like that on the quiz, the test, and the AP test. Just explain what's going on. Using 4 trapezoids to estimate the average melting rate of the snowman over 10 hours. So I want the average of what I have. The average of what I have. Which means I want 1 over 10 minus 0, the integral of 0 to 10, mt dt. How do I integrate a table? I can't do an antiderivative. I can't plug it in my calculator. It tells me to use trapezoids, so I'm going to use trapezoids. 1/10 out front. Remember, the bases of the trapezoids are the height or the y values. So negative 2 plus negative 3 all over 2 times 1 plus negative 3 plus negative 5 over 2 times 2 plus negative 5 plus negative 1 over 2 times 3 plus, I'm running out of room, negative 1 plus negative 6 over 2 times 4. If you plug all of that in the calculator, you're going to get negative 3.35. What are the units? Since this is an average, it's the same as what I had, inches per hour. So there's an example of average value formula, both with an equation and with a table. So in the equation, I had to use derivatives and integrals or my calculator to do it. On the table, I had to use RAM or trapezoids to integrate. You have to be comfortable with both methods. How to do it algebraically, how to do it on a calculator, and also how to do it from a table. Very, very, very important concept. Very easily confused. If you have any questions, come see me. Thanks, guys.